What's up guys? Welcome back to my channel. Today we will compare the difference between ROS1 and ROS2. We know that the biggest difference between ROS1 and ROS2 is that ROS1 is a centralized network, while ROS2 is a distributed network. In ROS2, we no longer need to run the master or manually set the IP address, which simplifies the operation. In addition, ROS1 only supports Ubuntu, while ROS2 supports Ubuntu, Red Hat, and Windows, and even macOS. So how big is the actual performance difference between ROS1 and ROS2? Today, we will use the transmission of RGBD video to test it. Let's first introduce our hardware platform. The router is a Netgear R7000 with a maximum Wi-Fi transmission bandwidth of 1.9 gigabits per second. Both tested laptops use AX211 network adapter. All the code used in the video has been open sourced, and the link is in the description. We use Wi-Fi 2.4 GHz and 5 GHz respectively to test the transmission of RGBD video. That is two 480p 30Hz video streams. First test is ROS2 rolling on Ubuntu system. While transmitting the raw image, you can see that the stream has a slight frame loss. After switching to compressed images, the stream is very smooth. After checking the specific bandwidth, delay, and frame rate, we can see that the bandwidth of compressed image has dropped by 90%. And the frame rate has also increased from 24 to 29.9. Then we switch Wi-Fi to 2.4 GHz. It can be seen that it is almost impossible to run under the raw images, and the program crashed on 2 attempts. After switching to the compressed stream, it was much better, but there are still lags and frame drops. After checking the bandwidth, delay, and frame rate, we can see that the bandwidth of the two is similar, but the delay and frame rate of compressed images are much improved. Next, we will take a look at the performance of ROS1 Nautic. First is 5 GHz Wi-Fi raw image. There is a slight lag, but it is almost invisible. After checking the bandwidth, delay, and frame rate, you can see that the bandwidth is lower than ROS2, but the delay is greatly increased, reaching half a second. And the frame rate also drops from 24 frames to 20 frames. At the same time, the two video streams compete with each other for bandwidth, and the bandwidth and frame rate fluctuated a lot. Then we switch to the compressed stream. The lag in the images is completely gone. After checking the bandwidth, delay, and frame rate, we can find that the bandwidth is greatly reduced, and the usage is lower than ROS2, but the delay and frame rate performance is not as good as ROS2. Then switch to 2.4 GHz Wi-Fi for testing. We can see the raw images is very laggy. After checking the bandwidth, delay, and frame rate, we find that the delay is 1 second, and the frame rate is only 3 frames, also with huge fluctuations. The last is the compressed images. We can see that the images is smoother. Check the bandwidth, delay, and frame rate. You can see that the bandwidth and the delay have dropped significantly, but the frame rate is still not good, only 15.7 frames. But compared to ROS2, it is more stable and the bandwidth is much lower. Finally, we put all the results together to summarize. Overall, ROS2 performs the best under 5 GHz Wi-Fi, whether the image is compressed or not. It is stable and usable, while ROS2 only works well with compressed images under 5 GHz Wi-Fi. When using 2.4 GHz Wi-Fi, both ROS1 and ROS2 are almost not usable. Both frame rates cannot exceed 16 frames. So at this moment, the performance of ROS2 is still better than ROS1 when the bandwidth is sufficient, both in terms of performance and stability, and it has the advantage of easier deployment. However, most open source algorithms are currently based on ROS1. So, would you like to use ROS1 or ROS2? Welcome to discuss in the comments. But what if I want both ROS1 and ROS2? Then we need to use the ROS1 bridge package to build the communication between the two. So in the next video, I will use the ROS1 bridge package to realize the transmission of compressed video streams and see how the performance is in this case. Please subscribe if you are interested. Thank you very much. See you in the next video.